Okay, so we're back here again with like a little video thing. So we'll talk a little bit about some problems. So we'll start with number 830. And so I know this last little bit of this been seemed, this stuff is kind of repetitive, but a lot of it is stuff you guys already know at this point that you've already kind of mastered. So we're just like sort of working through some examples, no big deal. So we look at 8.30. This is on page 362. And we're asking, for how many men, what's the male's ideal number of children? So we have 530 men. And we know that, based on a response where it was between 0 and 6, the mean, so x bar equals 2.51. And the standard deviation equals 0.87. And this question asks us a few things. So first is find the point estimate of the population mean and show that its standard error is 0.038. So we already know that what we're looking for on this, right, is that it's telling us we're going to be wrong if we don't have this. So it's saying that this is what we are aiming for. So how do we go about solving this, right? So we have, for number A, so the point estimate is pretty easy. So the point PE is 2.51. We already know that because they told us that's what the mean was, and so that's what we would estimate what it is. Then if we are finding the standard error, recall that this formula is S, so the standard deviation divided by the square root of n, right? And if we plugged all this in, this would be 0.87 divided by the square root of 530. And this is equal 0.038. So pretty easy peasy lemon squeezy. Part B. So it says 95% confidence interval. So we have this CI is equal to 2.43 to 2.59. So we have that. And it's asking us, what does that mean exactly, right? So if we have a 95% confidence. So for this one, and this distinction is actually clear, recall that the confidence interval applies with repeated random samples. So this assumes that we're sampling over and over and over and over again, and over and over and over again, right? So what this is saying is that if we kept drawing a sample, under the same conditions, right? Construct, and if we kept constructing 95% confidence intervals, right? The proportion of those samples containing the true mean would be 0.95 or 95%. So I know that seems a bit pedantic and really small, but that is the correct interpretation, and so it's really important you drive that home because it's something to keep on, and people make a lot of mistakes with that. So I'd really, really be stressed that you are understanding what exactly it is perfectly. Otherwise, you can lead to just mistakes and interpretation. Okay, what would be like another one here, right? What would something that we could do? Let's see. If we pulled out 8.39. Sure. Okay, we can do 8.39. Why the heck not? So 8.39. Is asking us for, we have this data file, right? And we have the software reports, and it gives us a bunch of information. And so with this information, right, says if we did it, we'll do our fancy colors. We'll do, so N, we know there's 60. For the mean, we know that it's 4.1. We know that the standard deviation is 3. The standard error of that mean is 0.388, and the 95% confidence interval is 3.307 to 4.859. So we have all this information in place. So it's asking us for this first one, right? So first one, A, is it plausible that the population mean, that's why we use mu here, equals 7? Does this make sense, right? Based outside of that. So we would say no. Why? Because 7 is well outside the 95% CI. See here? This is 7 is way out of there, right? So there's no way that should be correct. Absolutely not. B. So if we look at 8.39, suppose that the sample size had been, so we got N equals 240. Okay. And we have this X bar is equal to 4.1. And the standard deviation, or S, is equal to 3.0. And then, so what would happen? Describe the effective sample size on the margin of error. So what happens to our margin of error? This is really important for the next section that we'll go over of error. So yes, yeah, that's the one we're working on, right? So if we do, since the sample mean is 4.1, so X bar equals 4.1, the standard error is, again, the standard deviation divided by the square root of N, and this is going to equal 3 divided by 240, which equals 0.194, right? Yeah, that should be right. So what we end up finding here, right, is that if we do this right, we end up finding that the standard error decreases, right? So if we look here at the standard error that we had before, 0.388, and it's now 0.194, right? So pretty easy stuff here, and so really not a big deal, right? And if we kind of came out and we wanted to do this confidence interval, right, it would be 4.1, which is going to be plus or minus 1.96 times 0.194. And, that's going to be what? It's about 3.7 to 4.5 or whatever it is, right? So that's how that would shift underneath that. So let's think about this next part, right? So if we start thinking about that, does it seem plausible that the population distribution of this is approximately normal, right? So, well, we'll skip that one. We're not going to do that. Basically, we do have a large standard deviation, but, we do, well, yeah, I guess we will. So we have a large sample-ish, and we could suspect normality because of the size. If it was smaller, so around 30, maybe less so, right? And then for number D, let's see, we'll skip that one. We won't do that one. So we don't really know that, and we'll think we're feeling pretty good here. And so yeah, we'll call it there. So hopefully you guys can work through some of these problems and be understanding what's going on. And see you guys next video.